the dendrites. I am a segment of the neuron that receives messages in order to become active. I conduct electrical messages to the neuron and cell body for the cell to function.
Howdy, I am the soma, also known as the cell body. I am the brains of the operation, and I am located between the dendrites and the axon.
Good afternoon. I am the long tail-like structure of a neuron called the axon. My job is to quickly take the message away from the body and deliver it to another structure.
What's up, y'all? I'm the chemical known as a neurotransmitter. I come in many different flavors that control the body. And I'm actually not part of the neuron, but I'm an essential tool. Don't shoot the messenger.
And together we are in charge of conducting the signal of a neuron.
In case you didn't know, neurons are created during our fetal development when we are in our mommy's bellies.
These are the same neurons you keep throughout your entire life. This is because the neurons are not able to regenerate the ones you already have. The ones you have are the ones you get.
Once you build connections between your neurons, they are able to conduct the electrical signal even faster. Shoo! Shoo!
Lights, camera, action potential!
To first explain how the neuron transmits its electrical signal, we first must establish a resting membrane potential.
The resting membrane potential is the starting point for all neurons.
You always have to start somewhere.
The place where the neuron starts is negative 70 millivolts.
This is established when different ions or electrically charged molecules move in and out of the membrane of a neuron. For the neuron, the major ions are sodium and potassium. Both of these are found in foods you eat daily.
Sodium is found in salt. Salty.
Potassium is found in bananas.
With that being said, action potential cannot be reached if the magical threshold number, which in this case is negative 55 millivolts, is not reached. There is a concept that applies here known as the all or none.
The all or none concept says that once the threshold is reached, the neuron will always fire the same way, no matter what.
There can be very many failed attempts to reach this threshold, but no transmission of the signal will occur unless it is reached.
Dang it.
Oh,
Man.
failed attempts.
Oh.
Yeah!
Racers of today's competition, are you ready?
Yay!
Transmission of signal, are you ready?
Yeah!
Failed attempt, are you ready?
Yeah!
All right, to the starting line. On your marks, get set, go! And we have a winner! The failed attempt never even made it to the finish line.
And explain just how the threshold, all or none, and action potential come into play together. Here's a graph we have made. This is the resting membrane potential, or also known as the RMP. This is where we reach the threshold.
And this, right here, is the spike of the action potential. You can see that it flatlines and then spikes super high once it reaches the threshold.
Dendrites composed of tiny antennas that can receive signals from other neurons. I use my tree-like shape that is relatively short and small to help me collect as many messages that I can. Or also called neurotransmitters.
That's me!
The process starts with me receiving the neurotransmitter from the receptors and passing them along through the neuron body, or soma.
This soma contains the cell nucleus, which is what makes all decisions and acts as the neuron's brain. Also, it holds the cytoplasm to help the cell stay alive. Once I receive the signal from the dendrites, I make the decision whether or not to pass it along. The axon hillock is where all of the electrical signals accumulate and help reach the threshold to continue through the axon. This happens really fast and usually takes less than a millisecond.
Here in the axon, the action potential is actually created. It is used as a road or path for the electrical impulse generated to travel. I have the different destinations. I conduct the message to other neurons, glands, and muscles. Sometimes I am covered with insulation, also known as myelin sheath. This helps the signal to jump across instead of going slowly across. It makes me move even faster.
I am a very special chemical known as a neurotransmitter. I was released from the axon terminal. See, these little things right here are me. Depending on what I'm made of, I will tell the next structure what to do. You go to the muscles. You go to another neuron.
She's so bossy. Get out of here, man.
This is how neurons communicate with themselves and other parts of the body. To get to the next neuron, I must cross what is known as the synaptic cleft. I am released into the space and cross to reach the receptors, otherwise known as the dendrites. You use me all the time in your daily activities.
I'm the dendrites.
I'm the big fat soma. And I am the axon.
I'm the neurotransmitter that's crossing the synaptic cleft to get to the dendrites. And together, we are in charge of conducting the signal of a neuron.